Okay, so for this next one, remember, always head north and swing to the right if you're not given an exact direction. Like if it doesn't say north, 50 degrees west. So if it doesn't say that, then just head north and swing to the right. So for the first one, it says that the first plane heads in the direction, I think it said 300 and something, 320 degrees. So we know this little remaining spot was 40. And then it said that the second airplane swung 200. So if we know that this was 180, right, from the straight line, we know that there's a little more 20 in there. So then we know that if this is a straight line and we have 40 and 20, which is 60, we know that this little inside of the triangle has to be 120 degrees, right? So I made it a little neater over here. Also, for planes, especially something traveling, when it gives you a rate, right? Over here it's 200, and over here it's 150 per hour. It then says we're traveling for 3 hours, so that's why over here you multiply 150 times 3, and that's why you label this side as 450. That's a common error. Since it's 200 times 3 on this side, we label as 600. So then if we're trying to find how far apart the planes are, right, after they've flown for a while, this is where they are. I'm calling that A. I always first say, can I do law of sines? Because it's easier. But if you can't, you go to law of cosines. When you're trying to find a sine, you're using the formula where you're isolating the little a versus cos A. So we plug in, we label our sides, and you always, again, remember you want to think about what angle you're using. So if we're using angle A, then we're going to, in the end, for the formula, be plugging in cos of A, or cos of that angle. Therefore, the side that we're isolating is also going to be the little a. So the side we're isolating is going to correspond to the angle we're using. And when we simplify and take square root, we get 912.41. That's the distance apart. For number 27, as we start to set this problem up, we are given some values, and then I always, again, try law of sines first. And remember when we cross multiply, and then we're trying to isolate the angle, and we do inverse of whatever we had multiplied and divided by 7. If it says error, that means no triangle can be created. So even though it looks like I have a connected triangle, it wouldn't actually be a triangle that could be created. Now for this next one, when we are dealing with, I think they gave us 3 sides, yeah. You know that your angles, right, if we label angle A, the little a corresponds directly across. So for big C, little c is directly across, little b is across from angle B. And when we're using the law of cosines, we always want to find the largest angle first. So I know that I want to find angle A first because the side lengths correspond with the angle. So since little a is the largest length, we know that angle A is going to be the largest angle. We then set up our formula and we plug in all of our side lengths, and we have to isolate cos A. And when we do that, we do all of our algebra in here. We say angle A is inverse cos of 0.0859, and we end up with 85.07 degrees. So I wrote that over here. If at any point you can switch back to law of sines, it's a lot easier. So now I can. And in order to find my next angle, angle B, I just picked one. I used law of sines, and I got 32.15. Make your life easy. I mean, you again could do law of sines to find angle C, but it's easy. If you have 2, just do 180 minus the other 2, and you get 63.78. I think that's what it said. Okay, so for number 29, we need to use law of cosines because we only have one angle right now. And for law of sines, I always like to use that first. You need to have 3 knowns in order to find an unknown. So we wouldn't have enough initially to do law of sines because that's my favorite. So the only angle we can work with is angle B. So we're going to need to do little b and cos B because all we have is angle B. So we need the cos B. So we'll plug in all of our values. We'll find little b after taking square root of the right-hand side. And now that we have that, at any point, if you can switch over to law of sines, that's much easier, which is what I did over here. And once I did that, I searched for angle A. And so angle A was inverse sine of sine 48 degrees times 15 divided by 22.86, which got me 29.18 degrees. So that's how we end up with angle A is 29.18, and then C you can just subtract from the other two, and we get 102.82. So now we have all the sides and angles. Now for number 30, which the formulas are kind of easy if you think about it. Here, right, we can plot where the x-axis we count by numbers, on the y we count by imaginary, right? So we go to the left 2, so that's negative, and down 2 root 3. Our r value, which is the hypotenuse, will always be positive, so we just use Pythagorean theorem to find r. R is the same thing as hypotenuse, so we get 4. And so we have this guy, and we also need theta. Theta is a little bit harder to find. So how I like to find theta is I think of that dot, right, -2 root 3 as kind of like cosine. And we know that tan is sine over cos. So if you do the right side of that pair over the left, you get square root 3. Now you have to remember we're in quadrant 3. So at what angle is tan square root of 3 in quadrant 3? It's at 240 degrees. Now if you remember about your reflections, we know in quadrant 1, at 60 degrees, our tan is root 3. So I like to just keep flipping it until I'm in the right quadrant. And I know if I'm in quadrant 3, where we had that dot, right? In quadrant 3, we're going to do 180 plus 60, which is what gets us the 240. So here we go. When we go in reverse, it's a lot easier. So we know that cos of negative pi over 3, which is the same as negative 60 degrees, right? I always like to convert to degrees because that's easier for me. We know that the cos of negative 60 degrees, we swing downwards for negative, is 1/2 comma negative root 3 over 2. We can just reflect the 60 degree value up here. And you just need to think to the right is positive and down is negative, left is cos, right is sine. So at negative 60 degrees, the cos is 1/2. So we plug that in here. You don't write cos 1/2, you just write 1/2. Because at that angle, that's the ratio. Then when we're talking about sine, at that same spot, sine is negative root 3 over 2. So we plug that in, and we put the I at the end. And then we just distribute in that root 8. So square root of 8 over 2 minus square root 24 over 2, I off to the right, right? When you have square root of 8 times square root of 3, 8 and 3 are both under the radical, so we have 8 times 3 under, which is 24. So then square root of 8 simplifies to 2 root 2, right? 2 comes out, so we get 2 root 2. And square root of 24 simplifies to 2 root 6. The denominators are the same, so we have 2 root 2 minus 2 root 6i all over 2. Plus or minus separates the terms. They're all divisible by 2. We're just looking at numbers in front. So that's how we end up with square root of 2 minus root 6i You could write it over 1, but you don't need to.